DILR dry adiabatic lapse rate, DALR, the rate at which an unsaturated, dry, parcel of air cools as it rises, or warms as it sinks, assuming no heat exchange with its surroundings. 9.8 degrees Celsius per 1000 meters, or 10 degrees Celsius per kilometer. SLR saturated adiabatic lapse rate, SALR, or moist adiabatic lapse rate, MALR, the rate at which a saturated, moist parcel of air cools as it rises. It is lower than the DALR because as saturated air rises, condensation occurs, releasing latent heat and slowing the cooling process. Varies, but typically around 4 degrees Celsius to 9 degrees Celsius per 1000 meters, average approximately 6 degrees Celsius per kilometer. ELR environmental lapse rate, the actual, observed rate of temperature change with altitude in the surrounding, non-moving atmosphere at a specific time and location. It is measured using instruments like radiosondes on weather balloons and is highly variable. Varies daily and regionally, average approximately 6.5 degrees Celsius per kilometer. DILR, SLR versus ELR in determining atmospheric stability. The core difference lies in their application. The DILR, SLR describe the internal temperature change of a moving parcel of air, while the ELR describes the temperature structure of the ambient, stationary atmosphere. Comparing the ELR with the appropriate adiabatic lapse rate, DALR for unsaturated air, SALR for saturated air, determines the atmosphere's stability. Unstable atmosphere, ELR greater than DALR, the air parcel cools more slowly than the surrounding air as it rises, becoming warmer and more buoyant. It continues to rise spontaneously, leading to strong vertical currents, cloud formation, and potential thunderstorms. Stable atmosphere, ELR less than DALR, the air parcel cools more quickly than the surrounding air as it rises, becoming cooler and denser. It sinks back to its original position, suppressing vertical motion and trapping pollutants near the surface. Temperature inversion is an extreme case of this. Neutral atmosphere, ELR equals DALR, the air parcel cools at the same rate as the surrounding air and tends to stay at its new level when displaced.